how do we deal with exoskeletons as they come in? How do we utilize them to make our workforce more effective, more safer, more efficient? And so a lot of our lessons learned are going to be from this talk. And we've been working exoskeletons since 2012. So, you know, when Jeff asked me, hey, can you put a presentation together that you can contain all of that knowledge in 20 minutes? I was like, no, that's impossible. So I took the best aspects of what I thought would be helpful for you guys and moving forward. So a couple of things that we're going to go through, and I'll try to contain to my time. Innovation through partnerships. A lot of folks can't do it by themselves. Same with Boeing. Can industrial exoskeletons counter ergonomic work risks? Hesitations and questions from the end user community. Assessing safety and performance through user-centered design. And achieving technology readiness through crowdsourcing. We'll skip over that piece. I was told by leadership I need to talk about this because it's very important, so I'll try not to skip too fast. But if you think about it, we've been working with government, we've been working with private partners, private industry partners, as well as collaborators from standards organizations, and then collaborators from thinking of it at a global level. And so what we've been doing is essentially trying to get towards that crowdsourcing piece. How do we achieve more and go beyond what our resources are capable of? So a lot of parallel processing. And so that really is what it's looking at. So thinking towards NIOSH, the National Institute for Occupational Safety and Health, thinking towards organizations like Wearable Robotics. So I know Keith, who presented earlier, he's part of that. And then other organizations that balance and juggle that safety with the technology side of the house. So exoskeletons, I mentioned 2012. So here's kind of a list of what we've been through. Lots and lots of exoskeletons have crossed our path. We tend to break them down into postural devices. I guess you could call it equipment handling devices or tool handling devices, and then manual material handling devices. So I like to call that MMH piece, that manual material handling, the unicorn in the bunch, because we're trying to find the unicorn, but I mean, we think it's out there. It's just not apparent yet. So we're getting there. You know, industrial exoskeletons is what we're talking about today, but beyond industrial exoskeletons, we have medical devices, we have the military systems, like Keith mentioned, and really this workspace is a constantly evolving workspace. You see guys coming in, going out, big fish eating small fish, a lot of that going on. And so what we're trying to figure out is where's this stable space, how's the market changing, and can we find a niche in that market to better enable our people, our workforce. You know, one of my tech fellows is actually in the room and he's recording me, funny enough. Brian Laughlin, folks got to hear him talk yesterday about augmented reality and how we're dealing with cognitive enhancement, cognitive augmentation. Mainly we're talking about physical augmentation, but how do you deal with that overall? How do you deal with human augmentation on a cognitive and physical level? Because whether you're wearing an exoskeleton or not, it's going to affect you cognitively. The usability of that system affects you cognitively. So, you know, beyond our workspace in Boeing, we also work with these other folks that work in agriculture, folks that work in search and rescue, emergency services, medical practitioners, construction, military logistics, as mentioned before, waste disposal, warehousing. All of these are lessons learned that we can use for helping us internally to Boeing, as well as crowdsourcing, again, sharing that capability and those lessons learned across ourselves. When we're thinking about exoskeletons and tailoring it to the job, there's a lot of considerations within the manufacturing workspace, within the service workspace for our products. We have complex shapes, you know, working around wings, for example. Can the exoskeleton, when you have this increased surface area around your body, can you squeeze through these little holes that you normally would do on a daily basis? Tool handling, can you use the normal tools that you traditionally use when wearing and using an exoskeleton, or do you now need to come up with some kind of adapter in order to use that? Going into complex shapes, so building our airplanes. I spent my internship over a decade ago working 747, working 767, some of our largest products, and it's absolutely amazing how much those products dwarf you. But getting into the nooks and crannies of those aircraft, as we build our airplanes, it may look huge, but as you start filling out the systems, that fuselage looking longitudinally down that barrel consistently gets smaller and smaller and smaller as that plane becomes more complex and more sophisticated. So being able to fit into those restrictive workspaces is highly important. Awkward postures. So whether you're working in a floor and you're having to lie down, whether you're squatting or kneeling, working overhead, working in a twisted fashion, those are all things that we have to do repetitively. We have to do them over prolonged durations, and these are all considered as ergonomic risks. And then the last is more on the MMH side, the material handling side, so heavy lifting, push, pull, lift, lower, carry. All those things are all part of the consideration for exoskeletons. You know, I mentioned lots of applications, or kind of alluded to the applications. What I'm thinking more in terms of getting you to build an airplane or getting you to build a fighter plane or a spacecraft, you look at the postural activities, as mentioned before, overhead wire bundling, fine motor skills, being dexterous with your hands and agile with your body, working near the ground, as mentioned before, hand tool usage, you know, riveting and bucking. Our planes that are aluminum, that's the traditional way of putting them together. We're coming up with new methods, you know, like friction stir welding. Definitely on the 787 side of the house, we're doing a lot of composites and working in 3D manufacturing. But you know, even with that, you still have to put big pieces together. So torquing, using fasteners, drilling, punching holes, all these are traditional tools that you don't want to have to go buy new equipment for 50,000 people to use. It's not logistically sound. Looking at equipment relocation, moving, work stands, tools, carts, and then I mentioned already about manual material handling. All those are important. But you know, aside from that, you have all that systems installation that you need to do, as I mentioned before, filling in the structure itself. The structures work on the outside, tearing a plane apart, putting it together, and then of course you have options with painting. A lot of our beautiful planes are well painted, but they're done by hand. And so until we get that automation in place that's able to do that in a more automated process, we got to have folks do it manually. And so how can exoskeletons help us there? You know, this is one example of an exoskeleton that we've been looking at for overhead work. And so this particular exoskeleton, you know, it offloads each arm up to about 15 pounds. It's great for overhead and in front of body work, but it's not a strength enhancer. You know, Josh mentioned the Iron Man syndrome. We see that all the time. So people think they're super powered all of a sudden when you wear an exoskeleton. But this isn't made for that. This is made for posture enhancement. It's allowing you to hold your arms up longer. So think of it more of as an anti-fatigue device rather than a strength enhancement device. Strength enhancers, I'm still waiting on those unicorns, but when they show up, somebody tell me, because it's really something we're looking for. How do you augment that capability when you need to move large objects or hold large objects? When we dive a little more into the ergonomics of what's going on, this is really the process that we're going through. We have a lot of individual considerations. Each one of us, I like to joke around and say, we have equations floating above our heads. That's basically our individual capacities, the ability to tolerate whatever we're exposing ourselves to. And so looking at occupational physical loading, organizational factors right here, and then social context, you know, all of these get processed by our body and get internalized and either become pain, or you actually improve the muscle, like strength training, or on a worst case scenario, it fails on you. And so the tissue actually breaks and we get injured. And so when you think about it from that standpoint, we like to call them essentially material handling. So thinking about it from like how we would an airplane. So you stress an object, you repeatedly stress that object, and over time, can you predict when it's gonna fail, when it's gonna break? The odd thing on that stress-strain curve, though, is we all have healing factors, something that we can't do on airplanes and a lot of products that are non-biomaterial. And so we have to take that into context, but wearing the exoskeleton, can that augment us in such a way that we're not necessarily enhancing strength, but we're enhancing time until failure? And so looking at it from that context, you're prolonging the effect so that you can expose yourself to that risky work, those awkward postures, but then essentially allow you to do it longer before you end up getting hurt. And hopefully you'll be done working before you even get to that failure point. So that's where exoskeletons potentially can take us. It's allowing us to use it like a PPE device, a personal protective equipment device, to allow us to be in that exposure a little bit longer. I mentioned PPE, but nobody really can define what an exoskeleton is yet. Is it an augmentative tool? Is it a PPE? You know, and if you think of it from a hierarchy of controls, at the top, you get rid of the risk altogether. I mean, that's what your aim is to do. It's to do engineering design that removes the risk so you don't expose the person to it. But if you have to expose the person to it, can you use an exoskeleton to simply allow you to stay within that environment, that risky environment, for a little bit longer, again, keeping you safe. So when you think about exoskeletons for purchasing, you know, what are your highest concerns? And that's really what you're looking at. What body part is your highest concern? Is it your back? Is it your shoulder? Is it your knee? You know, use data to identify where you're planning on going. I like to say I like to drive with data. Use that data to basically say, hey, I'm interested in exoskeletons, particularly for posture assist. You know, looking at Liberty Mutual does a generation of the most injurious things to the population, to the US population. Overexertion is right here. It's number one, the most costly injury to the body for human workers in the US. Looking at awkward postures, that's right here. And then repetitive motion is right there. Altogether, that represents about 32% of the costs that we spend on injuries, which is about $19.5 billion. So just focusing exoskeletons in on those zones, whether posture, material handling, repetitive motion, that would help target a lot of our workers and enhance them. Other things that we could be thinking about are such as vibration right here. Would exoskeletons be able to dampen some of the work exposures that we go to? So things like riveting, bucking, drilling, all those things where vibration is a risk, could we potentially use exoskeletons just beyond strength enhancement, beyond posture enhancement, but also vibration dampening? Let's skip over that. Here's a taste of what it looks like from our perspective from injury data. You know, my leadership only allowed me to release so much, but back, shoulders, and knees, like I mentioned before, that's where it's all happening. That's the action zone. And then you can break that data down. If you do great data analytics, you can massage the data so that you can squeeze out additional information. So for lifting and carrying, when we look at lifting and carrying types of injuries, we have a lot of things dealing with the systems that we're installing into planes, the systems that we're installing on the outside of the planes. You can break that data down. You can look at pushing and pulling, overexertion, awkward postures, and massage the data to the point that you can say, look, I'm going to put postural assist exoskeleton right there. And over there, I want to put a strength enhancement system. And over here, I want to put something that would help with dealing with the shoulders. And so that's where driving with data is really helpful to moving things forward. So safety-driven approach is where we start. Strategic alignment, figuring out the program, the spots, the location to place that in. And then the best technology for the application, because these technologies are in constant evolutionary state. They're always coming out with something new, enhancing the usability and the product features. You know, from a COTS perspective, that's what I'm really interested in. I look at things from a technology readiness level, from a manufacturing readiness level. We want to make sure we put a sustainable product out there. And so the COTS-ready devices are the areas that I primarily look in, or commercially off the shelf. So hesitations and questions from the community. Here's some things that you guys might be thinking about. Can it work with my personal protective equipment that I currently use, such as my fall harnesses? If it can, then that's perfect. But a lot of exoskeletons aren't designed to be used with current personal protective equipment. Tools was mentioned, pockets that Josh mentioned, that's great. That's definitely something you want to be able to use. How should industrial exoskeletons be categorized? I mentioned about PPE or augmentative tools. Who will maintain these? So we're going through a sustainability process right now. How do we inherit exoskeletons? How do we maintain them? What are the consumables we need to think about? And who's going to wear them? Are they check-in, check-out processes? We want to make sure we're spending the right money in the right place, but we don't want these things to walk off the site and all of a sudden disappear and we're having to replace them. What's the extent of integration within the organization? Are you ordering 1, 2, 10, 1,000, 10,000? These are all considerations depending on your space. And then, you know, again, looking at how many should be ordered. I'm taking a look at the time and thinking about where we're going to. So, moving forward, when you personalize a system, I have to think about 50,000 people at one time when I'm purchasing these systems and when we're negotiating for these systems. Can they fit a majority of the population? This picture right here represents women that fit in a spacesuit of the same size. The spacesuit does not change size at all, but you have these different shaped women that can fit in that spacesuit. But with an exoskeleton, you have to think of it in the same way. You might have a series of people who are 5'10", 180 pounds, but they all have different shapes. And so you have to account for that and how the exoskeleton fits on that person. Because ultimately, it would affect their functionality if it doesn't fit them well. What happens over time? So we might look at an exoskeleton, try it out for a day, maybe a week, but really what happens after that? What happens after a month? What happens after 6 months? What happens after a year? These are the things you have to consider. How does the body adapt, both cognitively and physically, to the work environment with these exoskeletons? And can we evaluate systems faster? We're trying to start to look into digital human modeling, considering how we can do engineering modeling with an exoskeleton and the body to take into account how do we drive the iterative design process faster so that it's more human-friendly up front, and we don't have to wait a year or 3 years for a good design to come out. So I had a cool video. Let me see if this plays. So this is kind of some of the systems that we're going through within the Boeing company. Again, these are all considerations we have to make. Age, gender, size and shape, system functionality and applicability, all those are considerations. So when you come down to it, this is kind of something with my other hat under ASTM F48, which is creating a global set of standards for exoskeletons. I sit as the chair for the Human Factors and Ergonomics subcommittee. And when we look at exoskeletons across those different domains, military, industrial, healthcare, or medical, how do we standardize the process so that anybody can evaluate an exoskeleton, so that designers can evaluate it, end users can evaluate it, or human factors, ergonomics practitioners can evaluate it. So standardizing that process so that it's simply a user manual that you'll follow. Brian mentioned I'm at Ohio State University. We're looking at some of that as a visiting scholar. What type of lab assessments should we be looking at? I'm looking at near-infrared spectroscopy, for example, looking at how blood flows through your body when you're using exoskeletons to understand how it induces or doesn't, helps with fatigue. Same with electromyography, looking at kinematics, kinetics. All those things are part of the equation to better understand how do we tailor the system. I'm going to skip past this. This is some of the lab stuff, taking into account for time. Size and shape, donning and doffing. Important features that you have to understand to make sure that system's able to be used. When you get into confined spaces or restricted workspaces, could they potentially create snag hazards? So those are other things that would be considered in the design process or the purchasing process. I mentioned exposure over time. This is something that I like to call the honeymoon effect. That first month, everybody thinks it's the greatest thing next to sliced bread, really. And then that second month, they're like, there are a few things that I don't like. And so that's where you start that personalization process. But right around that third month, right around here, these gray bars, you start to see it kick back. And that's that tailoring that happened between month 2 and month 3. So these are things, again, that you have to consider over time because that customization isn't always up front. It happens with time as people become more aware of how that system is fusing to their body. I'll skip past the lab piece and end on this piece. Just to size it up again, thinking about it towards like a research consortium like Keith mentioned earlier, or like a crowdsourcing process. ASTM is one avenue. that we're looking at from a global perspective. So we look at the exoskeleton from a life cycle perspective. So design and manufacturing is on the front end, training, maintenance, IT security, those are things on the other end. I mentioned human factors and ergonomics. As the exoskeletons become more and more intelligent, how do we deal with that data as we're starting to consume it? How do we turn that data into information? You start to see disruptive technology crossovers and convergences. So exoskeletons, augmented reality, artificial intelligence. Again, these things are merging to help us become better performers and work more safely. But ultimately, how do we deal with the data? And IT security is an important piece of that. And then the last piece is looking at it from the human factors perspective. We want to make sure we go from functional design on one end, where we get a system that works, to a user-centered design on the other end. So part of that is, again, thinking about your size and shape of your population, the anthropometry, thinking about the usability and how you interact with that system, the safety, the ergonomics, and then, of course, the training. Because you're looking at sustainability. It's not an immediate purchase you're just using one time. You're going to be using it for months and years at a time. So I'll skip to that. And this is where I'll really end it. So the Boeing approach is internalizing it within our company, understanding how we can learn from others and bring that back home to make our company more successful and our people safer and more effective. But ultimately, we also help each other. A lot of what we do are two-way avenues of data transmission, information sharing. So you go from Boeing at the bottom to private industry, to academia, government agencies, standards organizations. All of us are like one big happy family, really. I mean, we're all learning off of each other so that we can better these systems to better enable us in the future. And so with that, I'll go ahead and close out, and I'll take any questions. Thank you.